Hello fellow problem solvers. So today we're going to be doing a problem from the 2005 IMO Shortlist, problem number N6. Though this is an N6 problem, I invite you to try it out for a minimum of 15 minutes, ideally an hour and a half to 2 hours, but not more than 3.5 hours. Actually, not more than 2.5 hours. If on the other hand you'd like to go along with us, I suggest you give it a go. Put your first couple of ideas out on paper for the next 10 minutes. And now without further ado, let's begin. So the problem states we have fixed integers a and b, and for every single n we have a to the n plus n divides b to the n plus n, and we must prove that this implies that a is equal to b. Now, one thing I'll ask you is, when you try problems that are difficult, when you try problems in general, one of the patterns that you're going to think of, and I'm just like writing this down because this needs to be equal to 0, if the problem is true. And one of the ways you can think about problems is ask yourself, how would I finish immediately? Is there a way that I can have some idea that can just like blow the problem up? And the way to think about this, okay, is like, let me see what this means. So a to the n plus n. Okay, let's look at some prime factors, some p dividing a to the n plus n. What holds true? Well, a to the n is congruent to minus n modulo that prime. Okay, now what is b to the n? So b to the n must be congruent to negative n as well, modulo that prime p. And now, is there a way to maybe force what n should be? Force n to be something that you want it to be, such that not necessarily the both of these can be true, but maybe they're simplified to something easier, something else. Like a to the n is also congruent to what? It's congruent to a to the p minus 1 is 1. So this is congruent to a to the n modulo p minus 1 modulo p. And now, is there a way that we can make this perhaps small? And if we can make this small, and correspondingly we would have that b to the n modulo p minus 1. If this is something small as well, both of these are small, then we would have this whole thing, b to the n minus a to the n, be congruent to something else modulo p. That could be limited. Like, we could have large primes which make this small, and so small that the difference is smaller than p, like the absolute difference is smaller than p, which would imply that a and b are equal. So this is just like thinking about how would I destroy the problem immediately. And I invite you to, pause for 10, 15 minutes and see if you can come up with anything. And the thing is, well, what's the smallest thing I can make it? Well, I'm picking n, mind you. I'm not picking p. But I want, okay, let me pick n such that this is n that is congruent to 1 modulo p minus 1 for some prime p. And then all of this is congruent to a, and this is congruent to b. And I need this to hold true as well. So what does that mean? I'll have a to the n will be congruent to a to the first is going to be congruent to minus n modulo p. So I need n to be congruent to negative a mod p, right? And if both of these things are true, mind you, such an n exists by the Chinese remainder theorem, and if not by the Chinese remainder theorem, like, you just have that among the numbers, this is what? P minus a, 2p minus a, all the way till, what do I need? Say p minus 1 minus a, this is 1 through p minus 1. So none of these numbers can have the same remainder when p minus 1 times p minus a. So all of these have the same remainder when divided by p. If two of them have the same remainder when divided by p minus 1, what would that give us? That would be like k lp minus a is congruent to kp minus a modulo p minus 1, which would mean that p minus 1 divides p times l minus k. And now these two are relatively prime, so p minus 1 divides l minus k. Given this is limited, that implies L is equal to K. So there exists one such that these two simultaneously hold true. Now we can pick such an n for any prime. Now all that give us? Well, that will give us that the prime p divides a to the n plus n, and this divides b to the n minus a to the n. Now b to the n is congruent to a to the n modulo p, but b to the n is congruent to b via this thing right here, and a to the n is also congruent to a modulo p. And now we have that b minus a is then divisible by p. And mind you, we can pick a very large p. So if we pick a prime number that's larger than both, say a plus b, larger than both a and b, then we pick an n, which is congruent to this modulo p and this modulo p minus 1, then we'll have this p divides b minus a, and now because b minus a is less than p, this implies that b minus a is equal to 0, which implies that b is equal to a. And we're done with an N6. And this just goes to show, like, even these humongously difficult problems, like quote unquote, like an N6, they could have solutions which are simple. Like, this is just one idea. It's one big idea that solves the problem. And a cool application of the Chinese remainder theorem. And the question you really ask yourself is, how can I solve this immediately? When you have divisibility, think in terms of primes, like prime factors or prime factor exponents, and that can solve your problems, like many times. It's a thing to think about in number theory, like one of the things. And this solves our problem, and as always, thanks for problem solving.